Hello, friends of podcast. Introduce section 6.3 in the Algebra 2 book. We are moving forward in our discussion of rational exponents, and we're going to start talking about what's called composition of functions. Recall from Algebra 1 and also earlier this year that if we had a function like f of x equals 2x plus 3, we could then find the value of f of x if, say, x is 5. And all I would do is substitute in this 5 wherever the x was. So if the x is here, if I want to put a 5 in, I just plug the 5 in. So this would just be 13. 2 times 5 is 10, plus 3 is 13. What we do in composition of functions is we, instead of inserting a number or a single variable, we put a whole expression in. So this causes us to have to use the algebraic rules to simplify a composition of functions. So what I'm going to do here is try to color code this to make it make a little more sense. So here they're telling us that the f of x function is 3x and the g of x function is x plus 3. And when they ask us to do these operations, they're just asking us to take the f of x and add the g of x to it. So you can see this is the 3x plus x plus 3. And all I'm doing here is combining the like terms. So I get this new thing, which is the 4x, the 3 plus the 1 gives me 4x, and then the 3 doesn't have any like terms, so that's what I get. Okay, so these operations are pretty straightforward. If I'm going to subtract the same thing, the one thing I want to remind you about is if I'm subtracting an expression, so right here I'm subtracting, and I put the minus sign outside of the grouping symbol, that means I have to change the sign of everything inside. So this becomes a minus x and a minus 3. So 3x minus 1x is the 2x, and then this minus 3 goes right here. For this multiplication, I hope that this looks a lot like the distributive property. And again, you can see the 3x times x plus 3. We've done a ton of this year, so this should not be difficult for you. And the same thing here in division. I'm just substituting in the 3x where the f of x is, and the g of x, the x plus 3 where the g of x is, and that makes a new function, which they're calling h of x. And again, the f of x or the g of x or the h of x just take the place of a y. So what you're looking at here is examples to 3 different questions. And you should be able to pause this, look at what they got for answers, and apply that to the practice problems I'm going to put up. The one thing I need to talk to you about is this little thing here called domains. When they say domain, they want the list of all the x numbers that work. What do I mean by that? Well, I cannot have a 0 in a denominator. So in this case, this function, f of x equals 1 over x, works for everything except when x is 0. If x is 0, this wouldn't work. The other function that has a restriction is a square root. A square root cannot be negative. So in this case, this function works everywhere except for where x is less than 0. In other words, negative, because I can't take the square root of a negative and get a real number. So when they ask you for the domain of f plus x and f plus g, when you get a simplified answer like this, they're asking you, are there any restrictions? And here, there are, because I have a square root. So there's just an x inside the radical sign. So just like this, the domain is everything as long as x is greater than 0. So how would I write that? Well, you could say x is positive, but of course, I'm going to give you some fancy set notation. So set bracket, that means all the numbers for x such that x is greater than or equal to 0. So this is the domain for this function. All values for x such that x is greater than or equal to 0. And it could also be written with a colon like that. Now these are some more examples with the answers filled in, and there's similar examples in your book. You should be able to pause this podcast, but I'm emailing you the notes, and you should be able to use these examples to do the following practice problems. So I'm going to give you one more podcast on the actual composition, but you should be able to do these 2 problems and bring them to class on Monday.